Welcome to homework.
Okay, we've got to draw the R configuration of this next compound. It's like a cyclopentene. Now, the first thing we have to do is find out where our stereocenters are. So any carbon that has a bond to 4 different things could potentially be a stereocenter, but any carbons that's got bonds to 2 or more of the same thing cannot be a stereocenter. Additionally, we can ignore these sp2 hybridized carbons. So I see this is a CH2, can't be a stereocenter. CH2 can't be a stereocenter. Now this carbon, it's also got a bond to hydrogen. I see a bond to like a isoprenyl? No. Basically this carbon as well as one direction on the ring, which is different than the other direction on the ring. So that looks like a stereocenter. Every carbon it's bound to is different in one way or another. And then it's got a hydrogen for its 4th bond. This is a CH2. This is a CH, but the other 2 carbon bonds are to methyl groups, which are indistinguishable. This is a CH3, so 3 bonds to hydrogen, and that has 3 bonds to hydrogen. So the one stereocenter we have, oops, I erased part of the molecule. So the one actual stereocenter that we have, I will color in, let's color in blue. Okay. Now, just for ease of seeing this, I'm going to redraw this hydrogen better. Oops. Okay. So probably the easiest way to go about this is to leave the ring flat. And then we're going to put a wedge to one of these substituents, either the hydrogen or the carbon chain, and then we'll put a dash to the other one. Okay. So to start with, I'm literally just going to put a wedge to one of them and a dash to the other and see if that is R. Just going to guess and check because it's just as quick as trying to figure it out in your head. Okay. So now I'm going to number the priority of these groups, ignoring hydrogen because it's in the back. Okay. So this is a CH2, and this is a CH2, and this is a CH with 2 bonds to carbon. So this is so far our highest priority. I'm going to write that as a 1 in red. Okay, now we'll continue down the other 2 chains, comparing them. On the left, we've got another CH2. And on the right, we've got a CH with 2 bonds to methyl. So this is the next highest priority. And then over here, we've got 3. Actually, let me do some erasing here so I can make that 3 a little closer. Okay. Great. Now, does this appear to be clockwise or counterclockwise if we connect 1 to 2 to 3? I see it as clockwise, like 1, 2, 3. It looks like clockwise to me. And clockwise corresponds with R. So this does appear to be the R configuration that I've drawn. So that's lucky. I mean, if I had drawn the other one, it would have come up S, and so we just would have had to have swapped the wedge and the dash. Anytime you, like if I wanted to make the S version of this, if I swapped the hydrogen to a wedge and the carbon chain to a dash, that would be the S version, because anytime you swap any 2 substituents and leave the other substituents the same, it'll swap the stereochemistry one for the other. Okay, that's it.